Hello everyone. The following video is a video I recorded with the help of a colleague of mine, Frank Latino. He is the Global Product Manager for Ethernet AP devices. The reason why I asked for his help is because I was working on setting up this module. This is an Ethernet AP module for the CPX-AP-I product family from Festo. So I was setting this up in the Studio 5000 software from Rockwell Automation, and I wanted to get some tips and hints from him on different approaches on how to set this up. The network that I was working in had different modules like this one. This is a 4 digital input, 4 digital output module, and it also had a valve manifold like this one. So hopefully while you watch the video, you'll find some interesting tips there, and you'll find it as helpful as I did. So thanks for watching.
Hey Frank, so today I wanted to reach out to you because I have this new platform which is called CPX-AP or CPX-AP-I, and it consists of different modules like this one here on the left, which is an Ethernet IP module, and then I also have a bunch of different I/O modules like this one with M8 connections, M12 connections, and then I also have a manifold interface for valves, right?
Okay.
And the reason why I wanted to reach out to you is because I have this module, this one, which is the CPX-AP-I-EP-M12, and this is the Ethernet IP interface. So I wanted to get your help on how to set it up on the Rockwell environment.
Okay, Sancho, should not be a problem.
Right.
Glad to help you.
Yeah, thank you. So what I have here is I already have some hardware laid up in my desk. I have a CPX-AP. So let me show you here on these pictures. I have this one, and then I also have one of this, an input module, and I also have a valve manifold. So I have these three devices.
Okay.
This one, and this one, right? So I want to. How do I start? How do I scan these devices?
So how do you have them connected on the API system?
I have so I have one cable. Let me go back here. I have one cable from this port going to my Rockwell PLC, right?
Okay.
The Ethernet IP cable, and then on this port on the XF20, I have daisy chain the CPX-AP-I modules one to each other for the communication.
Okay, that's fine. So that's your primary port.
Yeah.
And you're going to go to, as you said, daisy chain to two different modules.
Yeah. An 8 digital input first, and then valve manifold next.
Okay, great. Well, to see what you have, you could use the web server first, but I guess you don't have an IP address set up in the node if it's out of the box, correct?
It is out of the box, yeah. I was reading through the manual and I noticed that out of the box it starts as DHCP, right?
Well, that's correct. That's an ODVA requirement, and all of our devices are DHCP out of the box. It should be pretty easy to set the IP address, though. You could use Rockwell BootP for starters.
Okay,
And I would start with that.
Okay, yeah, we can do that. Let me start BootP then. So let me look it up. BootP DHCP from Rockwell. I opened that up, and right now it seems like it's scanning the network, right?
Mm-hmm.
Okay.
It should pop up in the discovery history box. You should see the MAC ID.
Okay. The MAC ID of the CPX-AP-I, right?
Correct.
Okay.
Oh,
so
there's something.
Yeah, there's something here, and if I wanted to make sure, I can always double check against what's printed on the device, right?
I would always recommend that. Yes.
Yeah, okay. So I'm checking the device right now, and it ends in 3A9D, and it starts with 000EF0.
That's perfect. Yeah, so you found the device, right.
Okay.
So double click on that MAC address, and you'll see here the IP address. Now you can enter it in. What IP address would you like to assign?
I'm working on this range, 192.168.4, on this range, so we can set this to, I don't know, let's say it to 13.
Okay, that's fine.
Okay.
So you hit OK.
All right.
And now it comes up in the bottom where it says entered relations. Now I would click on that.
Yeah.
And at this point, what you want to do is to disable the BootP DHCP request. So you see the button on the right says disable it?
This one, yeah.
Yeah, click that button. And I've seen sometimes even I get messages with Rockwell devices that says it's unable to service the device. So,
Okay.
but hit that button again.
Again?
And
Okay, command
um,
successful.
there you go. So I think now you've got this device is now set up for that IP address.
Okay.
You can check it different ways. You could even check it with our FFT tool.
Ah, okay. So FFT is Festo Field Device Tool, this one, right?
Yep.
Okay. So that would be one way, and then the other way would be just to ping it with command
Sure,
prompt or something
sure.
like that, right? Okay. There it is. So
Oh, there it
413.
is.
So it
Okay.
did take it.
Okay, if you want to be double sure, you could always turn it off, turn it back on again to see if it comes up with the same IP address now.
Okay.
But I'm pretty sure it will. Or else, if you just click on this, or
yeah.
maybe it's right click and go to network.
Oh, there it is.
And it says it's going to use the
Use the
following
following.
IP address. So it looks like it's static for me. So I think you're good.
Okay.
Yeah. So
Okay.
you hit OK.
Right?
Mm-hmm. And you shouldn't need this tool anymore, so you can close FFT if you like here.
I can close it, all right.
Yeah.
I'm not gonna install any updates at this time.
Okay.
All right. Can I close BootP as well?
Yes, you can. Mm-hmm.
Okay. Do I need to save
no,
the changes?
I don't think so.
Okay.
Okay, so now you have an IP address. So I like to use Google Chrome. I believe you have that as well, right?
I have it, yeah. So,
And let's see if you type in the IP address that you just created.
okay, the 413, the one that I
Yep.
assigned with BootP, okay.
Yeah. Oh, look. So the web server of the API has now come up, and it shows you a listing of the modules that you have online in order in proper order. And so, of course, slot 1 is always the Ethernet IP adapter. Slot 2 in your case is the 8DI, and slot 3 is a valve terminal, VAEM or VTUG valve terminal.
Okay.
You can see some other information that's as well, the firmware version, different serial numbers, and a product key.
So this is pretty neat because without me having to go and scan and register every single device or whatever, it automatically recognized everything.
That's right. Yeah, and if
Okay.
you click on each slot, just click once, you will see the parameters for each slot.
Oh, so if I go to, for example, okay, these are the parameters, the parameter number,
Yeah, with
and the
its parameter
parameters.
ID instance, the actual parameter name, and the values to the right. And that'll exist for each one of these.
So if I click on the other one, on the second one, there's also some parameters
whatever
on that
parameter
one.
exists, correct. Okay.
Got
Yeah,
it.
very
So
good.
every module has parameters. Okay, good.
Okay.
So now, I guess what's the next step? How do I bring this configuration into my Rockwell environment?
Yeah. So there are several ways to do it. Why don't we just start with the easiest way, I think, which might be just to use a generic setup. So
Okay.
if you go to your Studio 5000 software.
Yep.
So here, and you can go to where it says you're offline. Yep. You go to Ethernet and right click, and you want to add a new module, and you can call it generic, or you can search for a generic module.
Generic, yeah. This is the way that you add any generic module, and here's the option, right?
Yes, you got the generic Ethernet module.
Okay, so double click on that,
Yeah.
or create.
Create, yeah. Okay.
And then here I can
Give it a
just
name.
assign a name,
Mm-hmm.
which could be anything that I want, right?
Yes.
So I can call this Festo CPX API, or
Right.
AP, right? Okay,
Mhm.
and then this is Festo CPX API network or
Okay.
modules, yeah.
Now, the COM format is the next thing you want to set. In this simple case here, we can use SINT, but you always
Okay.
have at this point, you actually do have a choice too if you want to use Diagnostics or not. I always recommend Diagnostics. Well, you could choose to use them with status or without status.
So if I select with status, that would mean I want diagnostics.
Yes,
Okay.
Yeah.
So I think nowadays, I think nowadays every most of the customers are using diagnostics on their machines.
I think so too, yeah.
yeah, why don't we go with the status just so you can show me this approach?
Sure. So let's
Okay.
pick SINT with status. Now, I'm picking SINT in this case because you have some very simple modules here, and the SINT data type kind of suits them well. If you had other modules, like an analog module or maybe an I/O link module, I would may suggest to use a different data type. Our new API system for Ethernet IP supports many different data types. And you can see there with the dints and the ints, the integer or double integer. But let's stick with let's stay with the SINT with status.
Okay, so this way we will be working with bytes.
Yeah, that's
right?
correct.
Okay.
Mhm.
All right.
Now, put the IP address in.
And this would be the IP address of the one that we assigned with BootP, right?
Yes.
Okay, 413.
13, perfect. Now we have to enter in assembly instances. If you're not sure what to set in at this point, I would say go back to your Google Chrome
Okay.
and go to the Ethernet IP tab and look at the
Okay.
assembly view.
Assembly view, got it.
Okay, so now the assembly view gives us all the information we need to set this table up. If you look at the pull down, you have many different, you can scroll down, you can see you have many different options to set. And it may look complicated, but it's really quite easy once you understand what we're doing here. So we said we were going to use the SINT data type because that's best reflected the configuration of the system, right?
Right.
So we're going to use then SINT, and you can see now for the input table and the output table, it tells you the assembly number plus the number of bytes that you need to add. So
Right.
in this case here, 100 will be the input, and you're going to have 1 byte of data. So
Okay.
you can go to the back if you want to go back to Studio.
Oh, okay. Here,
Yeah. Mm-hmm. And enter in 100,
100
and then 1 byte of data.
and 1 byte of data.
And then
But
the,
would
yeah.
would that be enough for, because if we go back to Google Chrome, I mean, let me go back. Where was it? AP here.
Mhm.
So I'm assuming that this module, I know that this is 8 digital inputs. So this is already a byte, right?
Mm-hmm.
And but I don't have any inputs here. This is outputs only,
That's
right?
right. Yeah.
Ah, that's
you,
why.
And you will see that the diagnostics will go somewhere else. So
Got it. Okay, so let me go back here. So that's why I'm only using 1 byte for inputs.
yes.
Got it. Okay, so I go back here. I set it to 100, which came from here. This one.
Correct.
100.
Mhm.
And then if this will occupy only 1 byte, that's where it came from.
Right.
This one. Okay.
And now the output will be 101.
Okay. How
Well,
do I
go back. Yeah. Now let's look at the output. Let's scroll down, and you see the 101 is the output
Oops.
for SINTs,
Yeah.
and this is 3 bytes.
Okay. Got it. And okay. I see now. Because of the amount of coils that I can have on that manifold.
That's right. If this has 3 bytes, or I guess
24
coils.
coils.
In this case,
Yeah.
right?
Yeah. So 8 times 3.
We have
right?
another
3 coils.
version that has 6 bytes, or 40, I guess 48 coils. So
48 coils. Okay, gotcha. So this says it has from coil 0 to coil 23.
That's right.
And if I go back here, I see on the part number it says BEAM something, and it says 12.
Right.
So I'm assuming
For
that this
12
is 12
slices.
valve positions.
that's right.
So it's taking 2 coils per valve positions. That's where the 24 is coming from.
That's correct. Yes.
Got it. So the output then, I'm assuming, is going to be 101 and the size of 3.
Correct.
Okay, got it. So here it's going to be 101 and with the size of 3. Got it. What about the configuration?
Okay. So in this case, let's not do any parameterization,
Okay.
but we can go back to your assembly view, and we can find what the assembly instance is. So hit the pull down there, and scroll down, please. And we should see a
Right here?
configuration at the bottom, 140. Yeah.
Uh-huh.
But in this case, we're not going to do 400. That's the maximum. We're just going to do 0.
Okay, so just to set a value here.
Yeah.
So 140 and 0 bytes.
Correct.
Right?
Now we're going to need status the diagnostics.
Okay.
So we can go back to the assembly view. And in the assembly view, we would like to see now, we have 2 choices of diagnostics. We can take diagnostics and status, or we can do just the global status. So basically, the global status is 12 bytes of data. That's a global value that could exist for every configuration you could do with the API. If you really want a lot of diagnostics, if you want to get additionally, you want to get diagnostics for each module, there's another 12 bytes of data for each module. So you can put, at this point, you can put in 130 for just the global diagnostics, and you'll get 12 bytes. Or 129 will give you 12 bytes of global diagnostics, plus another 12 bytes for each module that you have.
Okay, so if I had more modules, let's say I had another additional module, this 48 would be 60 instead?
That's correct, yeah.
So every time that I add additional modules, it's an additional 12 bytes?
Yep, that's correct.
Okay, got it. And what would be the difference between 130, this one, global status, and these other ones over here, global status with input exact? For example, this one, input exact, int, global status.
So we put a provision in, that's a good question. What we did was we tried to accommodate every controller possibility. So in this case, the Rockwell controller has a separate assembly instance for status. If it did not have a separate assembly instance for status, you could add the global diagnostics into the input table.
So instead of putting the 100, that's where the 1 byte is coming from.
Correct.
Okay, so instead of assigning the 100 separately, I would put everything together, the inputs and the diagnostics on the same.
That's correct. And some simpler controllers may not support an extra the status assembly instance, but it's important to get diagnostics, we think. So we give the option for you to do that.
Okay, so this would be in most cases if I'm using another controller, not a Rockwell controller.
Correct.
That supports Ethernet.
Correct. Maybe Omron or a Mitsubishi one, depending on their capabilities. I think you would maybe use that other assembly instance for that.
Gotcha. Okay, I got it. And so this was exact synth and global status 13 bytes. What about these other ones? Because these are synths as well, 16, 32, and 64.
Okay, so now you're looking at the fixed assembly instances. We can get into that as well later on. We have the option for you to assign more memory than what you need, so you can add modules on at a later date.
So just make a reservation of data, so later on I can add modules.
Correct.
Okay, I gotcha. So right now we're gonna go with 130. That's what I got.
Okay, so you're gonna use, we're just gonna use the global, just a global diagnostic. Perfect.
Yeah, is that fine, or should I go 129?
Yeah, that's, well, 129 will get you the additional diagnostics if you want to do that. You could take a look at what you could do 129 also. You don't have a lot of memory in this case to take up, so why don't you do 129?
Okay, 129. I'll do 129.
All right.
So 129 would go here, and then the size would be what's being specified here, the 48 bytes.
Correct.
Gotcha. 48 bytes.
And now for the status output, in this case, we just have to know that gets 254 is the value there. Is assembly instance 254, and you see that there's no size.
Okay, is this, and I'm guessing this is specified in the user manual?
It should be.
Okay.
Okay, so you hit OK.
Okay.
And I suppose you'll get this next page here. You can keep the defaults here. Unicast is great. We use a 10 millisecond RPI is fine for your application, so I would say okay.
Okay.
Okay, so if you want to compile this, download, and see if we are able to turn on some I/O.
Okay, yeah. So it seems like it's good. Let's see if I can download this. Okay, download. And go back to remote run. Okay, so let me see. It says I/O. Okay, that's always a good sign.
Good sign
right?
at the bottom also. It says that the status is running. If you see that in the bottom.
Yeah, here.
Yeah.
Status of
And
this
what is the
running.
LED status on your API module right now?
So on my, let me pull up an image so I can show you. So these are the LEDs that I have. All of them are, most of them are solid green. This one, TP1, is flashing.
Okay.
Which that's the communication, I would assume.
Yeah, so that's showing that there's traffic, Ethernet traffic. That's normal.
Okay.
And
TP2 is off because I don't have anything connected to the second port, I
Right.
guess.
Correct.
And then MT is off,
Okay.
which is what, maintenance?
I believe so.
Yeah. Okay. So that one is off,
Good.
and all of the other ones are solid green.
That's perfect. The NS one is what we want to particularly look at this moment in time. The network status LED. A solid green LED means that we have a connected device that's properly communicating.
NS. Okay.
Yeah, for network status. That's right. So
Perfect.
That's good.
Okay. So that means that I could probably go to what, my controller tags
Yeah.
and see if I can force some outputs.
Yep. So you can see, yeah, you can go to the output table.
Okay.
And
Output data.
You should be able to turn on a valve in this case.
Yeah, I can do that. So
Okay.
I see coil switching on.
Mm-hmm.
Yeah, and then I see 2 coils. So yeah, that's good.
Okay.
Seems like I have communication.
All right. And if you had an input, I don't know if you have anything hooked up to an input, you would be able to see an input come on as well if you went to the input side.
No, unfortunately, I don't.
Okay.
Actually, you know what? Yes, I
Paperclip
do.
works.
Yeah. Hold on. Give me 30 seconds.
Okay.
Hey, Frank.
Okay.
I had to run to the to my other office. I have a homemade button, so I should be able
perfect.
to. Yeah. So there, I'm. Let me see. Go to the inputs, input data, and I'm pushing
I
a
see
button
it.
right now.
Perfect. And there it is.
Yeah. So I theoretically I could change it to any other position. Yeah.
Okay.
All right. That's
So,
good.
are you able to open up the status table here? You
Open the
see-
status table.
Yeah. And here, if you open that up, you should see all the possible diagnostics. Well, one thing that you can see, you see the 1 and the 2. That's a module number. So
Okay.
that's pointing to diagnostics that are in the for each individual module. And the beginning of it starts with the global diagnostics. Actually, if you refer to the app note that I have, there's an explanation of some of the diagnostics of the for the API system.
Do you know which page is that it?
Let's see. Well, it's section 6, so page 21. It's the beginning
Okay,
of
I'm
it.
there.
Okay. And
Oh,
if
here
you
we
scroll
go.
down, here we go. You can see here. So you see how in this case here I have some of the styles set to hex in some cases. I think this might be a little bit easier to read some of the diagnostics, and it will
Okay.
enable you to match up with the error codes that are in our manual.
Okay.
If you're able to create an error now, one of the easiest error is to create maybe is to remove the pin, the load power, not the PS but the PL. You know, I don't know if you're able to switch that off easily. If not, you could maybe disconnect the AP connection between module 1 and module 2, and there you'll trigger
Okay,
an error also.
I'm going to disconnect the communication cable to the manifold, which is the
Okay.
last module.
Okay.
And I should see something going
You
on
should see
here,
an
right?
error. Yeah, you should see an error pop up. That
Where?
Well, you'll see it pop up in several places. The global data will trigger an event.
Okay, I'm going to disconnect it now.
Okay.
So let's see. I'm disconnected. Okay. So now I have a red LED. So let me show you where. So this SD is red now.
Mm-hmm.
is the LED, and that's about it. On the manifold, I also have a red LED.
Yeah, okay. Why don't you go to the web server?
Okay, go to the web server.
And while you're here, go to the system page, pull
System.
down, diagnosis,
Diagnosis.
and scroll down. We should see an error there
Oh.
too. And you can see right down there, it says module 3 has been disconnected, right?
Right.
Yeah.
Okay.
So now if you go to back to the input table or the status table of the controller, well, it's going to be hard to decipher because we still have the native data types SINT, but if we change the styles here to maybe hex, it can be translated to, you'll be able to translate this to the actual error codes. You would have to do a few more changes over here to see them all, be able to compare this to the user manual. But I can show you, guarantee you that'll match the user manual.
Okay.
And you'll see the error code. Okay. Okay. So now that we were able to see some errors here. This particular error, to recover from this in this native format, you have to recycle the power to the API. So maybe you could reconnect the cable.
Okay, I reconnected the cable,
and it won't correct itself, heal itself. You'd have to recycle the power in this case.
okay. So let me recycle the power to the whole AP
whole
network.
API system. Yeah, there is a way of recovering from this, and that's documented in the AP notes that were done. You could read that later on. You can see how to create a program to recover this without having to recycle the power.
Okay,
Right.
got it. Yeah,
But-
because that's gonna come in handy.
Yeah, I mean,
later on.
it does. Even the recovery will always still disable some outputs or disable the connection for a few seconds, but you can recover it without having to recycle the power.
Okay, got it. So I already did the power cycle to the AP. I don't know if you noticed, but the I/O was not responding, and then after I power it up again, everything is fine now.
Okay.
So
Good.
the problem went away. Yep.
Okay, so that was the easiest way to connect to the system.
Okay.
I'd like to show you a different way.
Okay, yeah. So I should go offline?
You can go offline, yep. But then also, let's go back to the web server.
Okay.
And in the web server, I'd like for you to go back to the Ethernet IP tab.
Okay.
And you see EDS file.
I do.
Yes, if you click on that,
Oh,
you
okay.
can download the EDS file from the Ethernet IP adapter.
So I no longer have to download this from a website.
That's
it's
right.
It's already there on the
already-
Ethernet IP adapter.
That's correct, yeah.
Okay, so yeah, that's good.
So you can save that EDS file, and this would give you a benefit of having the device shown in the list of the Rockwell system, and you could use what's called an EDS AOP for configuration. So I think it's becomes a cleaner look when you do your configuration.
Right. So now I have the icon
Yeah.
and everything. Okay.
I guess they give you a better
So-
user experience. Yeah.
Yeah, I mean, this is what I do with any other device, right? So basically, the first thing that I have to do is register that EDS, right?
Right. So you know how to do that here?
Yeah. Go to Tools, EDS Hardware Installation Tool,
That's correct. Yep.
and then I'm gonna have to look for that folder. Yeah, because that's what we do for any other one. Register an EDS file and single file browse. It's gonna ask me for the location. Oops. Temp. Oh, hold
If
on.
it's a zip file, you have to unzip.
No, right. The thing is, I'm using a virtual machine here, so I need
okay.
to bring it into the virtual machine. So, documents, virtual machine. I'll just drop it here, and this is the folder that I'm sharing with my virtual machine.
Okay.
So browse, virtual machine. Here it is. EDS.
Okay.
And I bring that in. next, next.
And then they pick the icon.
It picks the icon, yeah, next. And finish, okay.
Okay. Now in this case, maybe in your project, maybe you want to delete
the generic approach?
Generic one, yeah.
Okay. Can I just, well, I can
Well,
delete it. Can I just disable it?
You're going to create the
Or
same IP
prohibit it?
address, so...
There's gonna be a conflict of IP
Yeah.
addresses. Okay, so yeah, let's just delete it. And then I'm guessing that now I have to just add it as
Now
instead of generic.
Yeah, you go to new module and you could search for CPX or Festo. Try
Festo, yeah.
Oh, there it is.
CPX-AP-I-EP,
Yep.
okay. So double click on that.
And now you see, you give it a name.
Yeah.
And then you can give it an IP address.
Okay. The same one that we defined with BootP.
Yep.
Okay.
All right. And now you want to go to where it says change. And here, you will set it up where it says IO configured fixed SINT. You can hover over that and you hit the pull down. And now you can do, if you want to set it up the same way, you can go to exact IO size. And you could do the same thing that we did before, or in this case, if you want to set it up with a fixed size, and you want to allocate some space to add another module later on, you could do that too.
Okay.
So if you'd like to try that, you can try the first entry there, which is the SINT for 16 bytes.
Okay. Yeah. Let's do that. So that way, I have an extra module here that I can add as well.
Okay.
So I'll do this one with 16.
Okay, great. If you want diagnostics again, you can hit the pull down below, and now you could add either status only or diagnostic data, which would be status and module. So
these are the global and
yeah.
So which one will be the global?
So just the global is status only.
Okay, and if I wanted per module diagnostics, then it would be diagnostic data.
Yeah.
Okay, so which one do you usually recommend going with?
Well, why don't you do status only in this case?
Okay, so the global.
Yeah, and it should be 12 bytes, and it is. In the other case,
so this is automatic, right?
Yeah.
Because of what you showed me earlier here.
It's always 12. Yeah.
So if I go here and I go to global, this one, it's always 12.
It's always 12, correct.
Okay, and just to recap, this is the one that changes, right?
Yeah,
The more modules that I add, each module will add 12 bytes, additional bytes.
That's correct.
Okay, got it. So that's why it's always 12. Okay, so this is always 12. I cannot change it.
Right. So
got it.
You can hit OK here.
Okay.
And
then
you would accept that. And you can scroll through the other information, connection, and module, but I think everything else should be, there isn't anything else to enter at this point here. So that's pretty much all you need to do.
Okay. So this is somewhat kind of faster, but it's cleaner in the way that you get the icon and everything is registered and everything, right?
Perfect. Yeah. Okay.
So same thing. I can download this again.
So let's download that. Yeah.
Okay. Remote run, and again I should be able to go down here, and this is my new.
Yeah. Now you see here, there's going to be two instances of the data. The first one will be. You see there, the SINT is 16
data.
bytes. Yeah.
Yeah, this would be the process data, and this is the diagnostics.
That should be the diagnostics. That should be 12 bytes. And you look to the right of the data type, you see it's an SINT 12. Yeah.
Got it.
That's right.
And so 12 because it's global, and so I can close that. And this one should be 16, right?
16, correct.
Because we set it to fixed.
That's right.
Although I'm not consuming 16, I'm just consuming 1.
Yeah.
It's allocating for 16.
Mm-hmm.
Got it. So again, if I press my button right now here, I should see some data.
Yes.
So I'm
and you
pressing
do.
the button there, and I change it to another position. Okay, so
All
it's
right.
working. And same thing with the outputs, right? So these are my outputs here, and I should be able to fire some valves. Oh, this is already, this is also allocating for 16 bytes of outputs.
That's right.
So
So
it's 16 inputs and 16
That's
outputs.
right. So if you hit the first one, you should be able to turn on the first
Yeah,
set of valves. Okay.
yeah.
Now, in this mode, what you're going to see here, what kind of other module do you have to add?
I can add another valve manifold, or I could also add a 4 digital input, 4 digital output module.
Okay. Would you like to add the 4DI, 4DO?
I can do that, yeah.
Okay.
All right, let me just grab the cables. Okay, so first I'm going to plug in power.
Turn the power off first.
Okay,
Of,
turn the power
of the
off.
API. Yep.
Okay. What happens if I add it while the power is on? Would it fault it? Do you know?
Probably. I don't know, but I think it will fault it.
Okay. So I add this power here. Okay, and then AP communication cable. Goes in here. I'm just daisy chaining my modules.
Mm-hmm.
All right, so I have the other module there. I'm going to bring power back online to the whole AP network.
Okay.
Okay, everyone is coming back online.
And I'm looking at the configuration on the screen, and I just saw the yellow triangle disappear on
Yep.
the API node. So I think if you hover over that or click on that, it should say it's running.
Yeah, it is running.
And now we want to be able to turn on that first output, let's say, right? So we were consuming 3 bytes of data before, I believe, right?
Yeah, so it would be
byte
for
0,
the
1.
manifold, right? So
Yeah.
0, 1, and 2.
So let's go to 3, correct, and see if you could turn on that first output.
Yeah,
Okay.
I can.
So what we just did was added a module and turned on an output, and we did not have to go back and change the controller.
Right, and that is because we did the fixed
That's
data
right.
size.
Yes.
So we did this this fixed cent 16, right?
Correct. Yes.
If I did it just like we did it on the generic, where I just set it to 3, I wouldn't be able to control this additional module then, because there wouldn't be any space.
Correct. It would look for the exact. It's the assembly instance that points it to whether it's exact or fixed. So if you use assembly instance 100 and 101, it's going to look for the exact size. But
Gotcha.
it's a different assembly instance, and you could do it in generic also. It's just a matter of picking the right assembly instance.
Got it. Okay. This is pretty cool, because that way I can set the data in case I need to expand I/O on my machine. I can do that later, and the data is already there.
Right.
So from a practical standpoint, that's good, because then all of my I/O is not shifted whenever I add an additional module.
That's right. As long as you add on to the end, or you start adding on to the secondary branch.
Okay.
If you don't insert a module in between 2 other modules, you will not disrupt the addressing.
Yeah, because that would be a nightmare when you do that and everything gets shifted, because
Right.
now you have to figure out where everything went to.
Right.
Perfect. Okay.
All right.
So I get this. And I'm guessing that the status would be similar to what you showed me on the generic approach, where I would get just the raw data, right?
That's correct.
Like right now, this is the status, right? The byte, this one right
Should
here.
be input.2. That's correct. Yeah.
Yeah, input 2. So
And then-
if I was to create a disruption right now, like
Yep.
drop the communication to the AP.
Let's see. If you
Okay.
separate one of the modules from the other.
Yeah, I'm gonna drop the last module that I added. So there.
Okay. And now we see
I did it.
information that the module is disconnected.
Okay.
And I see a number 4 there. That would be the 4th module, right?
Ah, here.
Yeah.
Yeah, because the AP module is the first one, and then I have digital input module,
Yeah.
manifold, and
Yep.
then the
And that's
module that I
number
just
4.
added.
Yeah. So it's telling
So
you there's
that's where
something.
these 4
Yeah, exactly.
Oops. That's where this 4 is coming from. Okay, gotcha. So now I can plug this back in. And then I do, right now, because I haven't seen that parameter, I'm just going to do a power cycle to the AP
Correct.
network.
Right. Okay. So this is an example. These are examples of a basic setup for the API system with Ethernet IP. But we have one additional feature in here that I think is very important, and it has to do with doing parameterization, which may not come up in every case, but if you have more advanced modules, or even in for this example without just simple outputs, if you wanted to hold last state, that's a parameter that you need to set. We have a nice new way of doing that here, and it's called using our L5X export function.
Okay.
So let me show you that. Why don't you go back to the web server?
Okay.
And go to the Ethernet IP tab. And then now you see the Rockwell L5X project.
Yes. Well, before I go there,
Yeah.
remember that I added that additional module?
Yes.
Should it show here now?
Oh, that's a good point. Go to the AP system.
Okay. Oh, it's right
there
here.
it is, yeah. Hey, while
I didn't have to-
and
yeah.
while we're here, that's a good example. That while we're here, let's go to module 3 and 4.
Okay.
And we want to change a parameter. So you see where it says behavior and fail state?
Yeah.
Instead of reset outputs, we want to change that to hold last state.
Okay, so this is a manifold. That would mean that if something happens, there's a fault on the communication. Hold last state would mean that whenever it fails, the coils will remain at the state that they were in.
That's correct.
Got it. So hold that state, and then it's asking me for a username. and
Okay.
password.
So username is always admin,
Okay.
and the password should match the product key that's on the label of the API unit.
Of the
adapter.
Ethernet IP.
Yes,
The whole product key.
the whole product key, yeah.
Okay, so in this case, it says 3S7PN31RRW9. So here's a good question, Frank, and I don't know if you know the answer for this, but what if this module was mounted inside of the machine somewhere really deep in the machine and I couldn't see the product key?
So we don't have an alternate way to get the product key for security reasons.
Okay.
So it would be something that, just like the MAC ID, maybe it's a good point to inform someone in advance to record these values if they're going to do that
Okay.
in advance. So you see, by the way, the product key is missing from the Ethernet IP module on the stream.
Yeah.
And that is purposely done as a security measure.
Okay. Is it possible to change this password or no?
It is possible to change the password, yes.
Okay.
I could
So
show-
maybe I just need to write it down the first time and that's it. I can change the password.
That's right.
Okay. So I clicked OK and then I saw something that said the parameters were
Yeah.
right.
If you want to go now to the digital output module and do the same thing,
Okay.
you can do the same and set hold last state, and you see that's the right success.
Okay.
So now you've changed the parameters, and you want these parameters to stick when you turn on the API system. So
Yes.
what you're going to do now is you will go back to the Ethernet IP tab,
Yep.
and now you would go to the L5X project.
Okay.
And here now you can create a name of a project, I would change the name.
Okay, test 01.
Okay. If I'd also would suggest to keep the global diagnostics and module diagnostics, so status assembly, you can keep that. You could turn it off here, but let's just keep it.
Okay.
And we want to enable the configuration assembly. We want to keep enabling the web server. We want it to be enabled. We want to have write access to it. And we could keep SNMP off at this moment. And then, so now you can hit submit.
Submit, okay.
And now download.
Okay.
And you should see, okay, here we have there's
Yeah,
your file name.
Yeah.
Wherever you save it, wherever you like to save it.
Okay, I'll save it here. Okay, save.
And save. And now you see, now you've just saved CPX-AP-test01, L5X. So that you can open up in your Logix software.
Okay, do I have to close this project?
Yeah, I would turn that off. I would disable it. I would close it.
Just gonna save it for now.
Yeah, okay, save it.
Okay, so and then open or
Open
close?
open a new project. Oh, yeah.
And it's this one, the one that I
Actually,
brought.
you could also open up another instance of Logix as well. So if you hit cancel, and then you right-click on the bottom of your Studio 5000.
Oh, here?
Maybe right-click on that.
Oh, just to open another one.
Yeah, open another component of that application. We may not be able to see it together here.
It's loading, I think. So now that L5X file, it is actually a complete project, right? It's not like an AOI or anything
That's
like that.
correct.
It's a whole project.
It's a project, that's correct. And what we're going to do is we're going to export things from that project. And the way to do that is explained in the app note that was developed.
Okay. So on this app note, I can find that how to use that L5X.
Looks like in section 4.
Section 4.
It starts 4.2.
That right here.
Yeah.
Oh, so this is what you showed me right now. Don't
Yeah.
download, and then you'll get the file.
Correct.
And then you open it. So we're here.
So we're at the steps at 4.2.2 where we're going to go through the Studio 5000 procedures to open that up. Yeah, 2.2.4 should be the next thing once you open up that L5X file.
Okay. Revision 32, which is the one that I'm using.
Yes.
And then import.
Right. So when you pick the file, the first thing it asks you is for a version number, right?
Yeah.
So you pick the version that you're working in, and you export it, and a project will come up, and you see the name is there, Ethernet module test 01.
Yeah. Oh, okay.
Okay. And you can double click on that.
Oh, hold on. It already has the the IP address.
Oh
saved.
yeah, and you can see that the table is going to be set up. Now,
Right.
Now you've added for the exact configuration. So you added that additional module. So now there's 2 bytes of input data and 4 bytes of output data.
Yeah, that's what I was going to ask you. Like, well, these numbers look different. So initially, the first time that we did this was with the generic, right? And when we did it, it was 1. But since then, we added this additional module.
Exactly.
So now it's 2.
Exactly.
Okay. Okay. And then on the outputs, I had 3 initially because of the manifold. And now with this new module, I have an additional byte of outputs.
That's right. But here, one big difference you'll see is that the configuration table now has bytes in it, 34 bytes.
Yeah, because initially we did it with 0, right?
That's right. Now we have parameters that we want to push down to what's in the forward open message, and those are the parameters. And then status input now is 60 instead of 48.
Okay.
All right. So you can see here that's all good. You can hit OK, but I would like to show you what else is created. So go to controller tags. Oh wait a minute, no, I'm sorry.
Okay.
Yeah, the controller tags will show the same thing. Go to main program and main routine, and you'll see a couple of rungs of data here.
Yeah.
These rungs will take the data and transfer them from I call it the raw data to user-defined data types that were created. And those data types are under assets and user-defined. And you'll see there's a status module, there's a status one.
Yeah.
And you can double click if you want to open it up to look at it. And now it has everything laid out in the right data size that you need to really interpret your diagnostic information.
Oh, so that the number 4 that we got when I disconnected the module just a few minutes ago, it would be shown now here instead of looking at the raw data. It will tell me which module it is.
Now I'll tell you. Now it'll be very clear. You'll see module number, submodule. You'll see the diagnostic error, and so on. If you go to the and by the way, that's the data structure for each module. If you go to inputs,
okay,
you'll see the data structure for the different inputs, but now it's clearly defined, right? So you see.
I'm gonna know which one is which instead of figuring out which bit is which.
Right. So
same thing for the outputs, I would imagine.
Mm-hmm. So you can cancel these data types. I was just doing that to show you what the different data types are. Now we have to transfer this stuff over. We have to transfer this into the project that you're working on.
Okay.
Alrighty. So to do that, the first thing we could do is we can go to the Ethernet module on the left in the tree.
Yeah.
And then you can right-click on that, and then you can say copy.
Copy.
And then you can go to the other project, and you can paste.
Okay. Well, I'm gonna delete this because this is the one that
delete that one, please.
This is the one that we created with the EDS file.
Right. So we can delete that.
Okay.
And now you can just right-click and paste.
Paste.
Yeah.
And that brings the whole
that brings
thing
that in
inside.
there. Right. Now go back to the L5X project.
Okay.
And go to these rungs and select these rungs. Select 0, 1, and 2.
Okay.
Okay. And now right-click and export rungs.
Export rungs.
Yes. And then, so yeah, this will create a routine. You could use a default name.
Okay.
And hit export.
Let me just make sure that I know where this is going to paste it. My documents 35,000 in projects, and then export. Okay.
Okay, and now you want to go back to your other project, your main project.
Yeah.
And now you want to go to the main routine.
Yeah.
And if you right-click.
In this case, it's open. Yeah.
Yeah. Okay. Right-click there, and import rungs.
Import rungs, and there they are.
And find that, yes, and hit it, open. And then hit OK.
Create. So it grabs everything on that other code and brings it into my project. So if my project had like 100 rungs already, this is how I would bring just those unique rungs.
These 3 rungs would come in, and the input ones should be at the beginning of the project, and the outputs, you should set the outputs near the end. Now, since we did this, I'd like for you to also look at the UDTs, look at your assets in your new project, in your current working project.
This
project.
This is my project assets.
So the UDTs came over as well.
And they came over with when I exported and imported the
rung.
The rungs.
Yeah.
Okay.
Yeah.
Yeah, that was going to be my next question. Like, how do I export the UDTs and bring them over here?
Yeah.
But it's already
very
done.
important to do it this way. Do not copy and paste over the UDTs. It will not work right.
Okay, so it's important that you not only go and do something like, oh, just right click and copy runs, and then bring it over.
Do that.
You have to export it and import
it.
Gotcha. Okay. Good.
Okay.
So now it seems like everything is in my main project. So I have these 3 rungs, I have the UDTs, I have my Ethernet device, and I would imagine that now if I go to the controller tags and I look into my inputs, for example.
So now you want to work. Now your customer wants to work with the UDT I/O, and not the raw data.
So not this one.
So not the one that's not that I/O. Correct. You want to look at the one that's called inputs, outputs, and status. That has a data type that is the data type. So now you see everything's going to be labeled module inputs, module 2, channel 0 to channel 7. And then you see the next one, module 4, channel 0 to channel 3. Now all of your inputs are clearly labeled, and you see in the description field the 8 digital input module, and then it transitions to the 4 digital in, 4 digital out. So everything is, the nomenclature is done for you.
Got it. So, but all of these are pointed to the raw data at the end of the day.
That's what the logic does. Yep.
Okay, now I get it. So the logic is grabbing the information from the UDTs and pointing it to the raw data.
That's correct.
And the other way around for the outputs is grabbing it from or from the inputs is grabbing it from the raw data and put it in the UDTs.
That's right.
Gotcha. Okay.
All right. So save this project, I guess.
Save this project. Okay.
And then let's try to download it.
Download it, yeah. So to me, it seems like the cleanest and more elegant way of doing it is with the L5X, because that way it brings all of the diagnostics. It also brings all of the tags, which is really important.
Yes.
This to me seems like the most elegant way, and it's actually pretty quick in a way. I mean, yes, I do have to go through the process of exporting and importing and all of that, but at the end of the day, it gives me a lot of additional functionality.
Absolutely, I agree 100%.
Okay. So, okay, it's running and everything says it's okay. So theoretically, I should be able to, again, push the button.
So now,
and now
yeah, if you push the button and now you see your button is on the module 2?
It is on the module 2, yeah.
Module 2, channel 4.
Channel 4. Yep.
Okay.
So 0, 1, 2, 3, 4, 5, yeah. Channel 4, and then this should be channel 0, I believe. Yeah.
Yep.
Channel 0.
Okay. So it points to the module that's being used, and then if you want to go to the outputs, where it says test outputs, and now here it should be very clear. You want to go to the VAEM. You want to go to channel 0, your first coil.
First coil. Yeah, I see the coil on physically on the manifold.
And you can go now you could go to exactly what coil you want to use here, because it's all laid out for you, which channel you're going to.
Yeah, I don't have to be
you don't have to hunt and peck.
Kind of hunt, yeah, exactly.
And now if you go to module 4 to the digital outputs on the last module, you can go to exactly which one you want to turn on, and you should see that one come on.
Yes.
Okay.
Yeah, no, definitely. I like this approach with all of the labels, tags already done.
And the same should work for the status and the diagnostics also.
Oh yeah, that's actually one that's really important, because previously when you showed me the raw data, I was like, oh well, this is gonna be a little bit tough to figure out which one is which.
Mm-hmm.
But now I get
and now you open up each individual module, or whichever module you want to create a diagnostic for.
Okay, let's do the last module so I can unplug that one.
Okay.
So now this one is telling me this is the module number 4.
Yeah.
And if I don't know what the number 4 is, I can always go back to here, right, to the web browser.
That's right.
And see number 4. It's this one.
Correct.
4 digital inputs and 4 digital outputs.
That's right.
Okay. So number 4, and it's submodule number 0, channel 0, present state 1, diagnosis state 1, diagnosis code 0. So if I was to disconnect this module from the AP network, I should get a fault.
Mm-hmm.
Okay, let me do that. There.
And there you go. And so now you see here it's decimal. Actually, it would be a little bit better if you change that decimal to hex. And by the way, I think this is going to be a change we're going to make in the next firmware. Now, that hex code will line up with the codes in the user manual.
in the user manual for the
Ethernet, for the API system, I believe.
for the whole system.
Yeah, there's a system
This
manual, and there should be, I think, error codes in this manual.
Okay, so diagnostics maybe.
The status. Here we go. Yeah, here we go. Yep.
So if I look up that code that it's giving me, which is hex 08010127, 08010127.
Yep.
This one.
Yep.
It says communication to AP module interrupted. The AP system communication to a module is aborted. Remedy, restart the AP system or check the cable.
There you
which
go.
is exactly what I did. I disconnected
Mhm.
the cable, so now I know how to fix it.
Right.
Got it.
Okay.
So can I create something more severe, like a short circuit with a clip?
If you like to.
Okay. Let me see. I thought I had a clip here. Yeah, I do have a clip here. So
But you still have that module disconnected, though, right? So you're not
yeah,
the same
I
thing, so
gotta
you might have to
bring it back
recycle
on.
power to it. Yeah.
Yeah, let me do that. Yeah, I just want to make sure that I see a different kind of diagnosis.
Sure.
Okay, I'm power cycling right now. And okay, it's power cycled and it should come back online
Mm-hmm.
shortly. So here I see that all of the errors went away. Right?
Yes.
So now if I do a short circuit on one of the inputs, let's say here, let me do a short circuit on the first input. There, I made a short circuit on input number on channel 0.
Okay.
So now it's telling me diagnosis code 0101010B.
Okay.
So I go back here, 01, 0101010B. Short circuit overload in sensor supply. There we go.
There you go.
Check connected, yeah, check sensor and wiring. So good. I removed the paper clip
Yep.
and the error one goes away.
Perfect.
Awesome.
Okay.
So yeah, I think that from here I can keep working on my project.
One final
yeah.
thing here now. If you remove the Ethernet IP cable, your outputs should stay on.
Right. Okay. So let me. Yeah, because we changed that parameter, right?
We changed that parameter from default of reset to hold last state.
Yeah, we did that where here and then here. Hold that
Correct.
state. Okay. So let me try that. I'm gonna set some outputs. So those two, I have two coils on two different valves, and then I'm going to remove the Ethernet IP cable to the AP module, right?
Okay.
So I disconnect that.
You're gonna disconnect the Ethernet IP connection to the
Yes.
API, correct?
To the PLC.
Yeah, correct.
So yeah, as you can see here, I/O not responding because
Right.
these modules should say I/O faulted, right?
Yes, which it does. Yep.
But the valves, the coils remain on.
Okay.
I mean,
Yep.
I see them physically here. so-
Sure. And that's exactly how it should behave. And that's a parameter setting that you've created now. And this is the way to do parameterization with the API system. Comparing it to the CPX, we don't have that modify.
Fast maintenance tool or.
Yeah, we don't have that modify feature anymore, that system save parameter that we used to be able to use to save the parameter on a device. But this is a much more secure way because it's really excellent for disaster recovery. If something were to happen to the API node, needed to be replaced, the parameters will always be there because it's pushed down from the PLC. It doesn't reside in the Ethernet adapter.
Right. So all of the parameters are written somehow here,
Correct.
right? On this
That's right.
configuration
That's
assembly.
right.
So everything here, I mean, there
Right.
must be a parameter here that says, yes, hold the last
And
date and all of
everything
that.
is documented here too, so you could kind of go through these descriptions, and you can open up some of these bytes and you'll see which parameter does what.
Right. Yeah.
So-
So the module code, the parameter length
Yeah.
for every single module.
Yeah.
Yeah. Yeah, no, you're right. That's cool, because if for some reason this module, the Ethernet IP module, fails, I can just replace that and all of the parameters are within the PLC code.
That's correct. Yep.
Got it.
So
Got it.
that's why I always say for disaster recovery, this is an excellent approach.
Yeah. Yeah, I agree. I agree. No, I think I think the three different paths that you showed me are great. I mean, there are differences between each other, of course. I think it would be up to every programmer to follow the one that they like the most. Personally, I think in most cases I will go with the L5X, just because of what I explained earlier, right? I mean, you get the UDTs, you get everything already imported in here. It takes me maybe 1 more or 2 more minutes to export and import, but it's just 3 rungs, so it's not a big deal. Right?
Absolutely.
And the benefits that I get are huge compared to the other ones.
I would recommend that way to go all the time. Yeah.
Yeah.
And it gets more
yeah.
critical when you have a larger configuration with different modules, and especially if you want to do parameterization, it's the only way to go.
Right. Okay. If I wanted to do parameterization, that would be the only way to go. Okay.
Yeah. Well,
Got it.
we could work out other ways with the fixed if you needed to, but this is by far the easiest way. Just the app note has other information on handling parameter information and some other diagnostic information with that's a little bit more advanced for this topic, for this
Okay.
scenario. But so anyone could always reference the app note, and of course the user manuals will have all the basic information that's needed to get started with this device or the system.
Yeah. Yeah, I mean, maybe later on we can do another session and you can show me some additional features. But right now, for basic operation, I think this is good.
Yes, great.
All right, perfect, Frank.
Great, Sandro.
Thank you very much, and
You're welcome.
and we'll be talking.
And okay, of course, and
Uh,
happy trails with your new Ethernet IP adapter for the CPX-AP-I system.
Thank you. I'm happy to start using this thing.
Great.
All right.
All right.
All right. Thank you.
You're welcome, Sandro. Bye-bye.
Bye.